Alright, this is section 3.7. We're talking about inverse functions. Okay, so the notation for an inverse function is this right here. It is f raised to a negative 1. So that is what we say is the inverse function of f. Okay, so and this is important right here, for any one-to-one function, in order to find the inverse of a function, the function has to be first a one-to-one function. Okay, so for a one-to-one function, f of x equals y, a function, f raised to the negative 1 of x, that is called, we just say it's inverse function, is an inverse function of f if the inverse function of y is equal to f. So this can also be written as that complicated thing right there. So that means that you put one function into another function, or you put the function into the inverse of function, that should come out to be x. And we're going to use that to check to make sure that two functions are inverses of each other. So for all x in the domain of f. Okay, and also you can switch it. You can plug the inverse function into the function, and that should also come out to x. So it should work both ways. Again, that's a check to make sure that two functions are inverses of each other. Okay, so this notation, like I said, is called f inverse, or the inverse of f. Okay, and keep in mind, we're used to, in college algebra, if anything's raised to negative 1, like x raised to negative 1, well, that's the same thing as 1 over x, except for not in this case. F raised to negative 1 is not the same thing as 1 over the function of x. Okay, these two things are not equal to each other. And also, not all functions have inverses. Some of them just don't have inverses. So let's look at this. So it says find the inverse of x if f of x is equal to 2 minus x. So the first thing we're going to do is we're going to change f of x to y. And then what I'm going to do is switch my x and my y's. So x is equal to 2 minus y. And then we're going to solve for y. So I'm going to add y to both sides. So x plus y equals 2. Subtract x from both sides, so y is equal to 2 minus x. Our last step is to say that f of x, the inverse of x is equal to 2 minus x, which in this case comes out to be the exact same thing. It doesn't always come out to be. Now, if we are going to check that these two things are inverses of each other, so I'm going to get my f of x function. If I place the inverse into the original function, so that means we would have this notation. So here's my original function. Everywhere I see x, I'm going to plug in the inverse. So 2 minus, not x, but 2 minus x, because that is the inverse. So that will give me 2 minus 2 plus x. These cancel out, and I'm left with x. Okay, and back here it says if you have, or this one, if you plug the inverse into the function and it comes out with x, well, then they're inverses of each other. And we'll do the opposite as well. Okay, so let's plug the original function, into the inverse, which would come out to the same thing because they're exactly the same in this case. So the inverse function is this one right here. So 2 minus, then wherever I see an x, I'm going to plug in the original function. So 2 minus x, and it comes out to the same thing. 2 minus 2 plus x, those cancel out, and I'm left with x. Okay, so what our final answer is to find the inverse was this right here. What we just did in this little part is just checking. So let's look at this one. We're going to find the inverse if f of x is x over x plus 2. So first I'm going to change f of x to y. And then I'm going to change my y's and my x values. So this is going to be x is equal to y over y plus 2. Okay, now we're just going to solve for y. So easy thing here is I'm going to multiply both sides by y plus 2. Okay, so this is going to be yx plus 2x is equal to y. I need to get the y's on one side and the x's on the other side. So I'm going to subtract 2x from both sides. So yx is equal to y minus 2x. I'm going to subtract y from both sides. Okay, so that's going to be x minus y is equal to negative 2x. I'm going to factor out a y here. So x minus, and there's a 1 in front of this, so 1. And then I'm going to divide both sides by this x minus 1. So y is equal to negative 2x over x minus 1. Then last thing to do for our final answer is change this y to the inverse of x is equal to negative 2x over x minus 1. And there's your answer right there. Now let me show you again about the checking to make sure that these are inverses of each other. You don't have to do this every single time. I'm just showing you how to do it. Okay, so we've got f of x is x over x plus 2, and the inverse of x is negative x squared, or sorry, negative 2x over x minus 1. Okay, so if we plug in the inverse into the original function, so everywhere I see an x in this function here, I'm going to replace it with negative 2x over x minus 1. So negative 2x over x minus 1 all over negative 2x over x minus 1 plus 2. Now let me move this because I'm going to need the room. Okay, so I'm going to multiply the top and the bottom by x minus 1 to get rid of the fraction. Okay, so that's going to cancel out here. I'm left with negative 2x over, it'll cancel out, so I'm going to multiply this times this function and times this function. For this first function, they'll cancel out, and I'm left with negative 2x and then plus 2 times this x minus 1. Okay, I need to simplify that just a little bit. Negative 2x plus 2x minus 1. So notice that, that should be 2. 2 times a negative 1 is 2. These cancel out, and I'm left with negative 2x over a negative 2. These cancel out, and I'm left with just x, which back here says, well, if you plug the inverse into the original function, you come out with x, then hey, they're inverses of each other. And then we'll try it the other way around. So if we're going to plug the original function back into the inverse, and remember the inverse that we just found was negative 2x over x minus 1. So wherever we see an x here, I'm going to replace that with x over x plus 2. So this is going to be negative 2 times x over x plus 2 over x plus 2 minus 1. And I'm going to move this out of my way. Okay, I'm going to multiply the top and the bottom by x plus 2, so I can cancel out those fractions. So in this first one, it'll just cancel out, and I'm left with negative 2x. Now I'm going to do the same thing. I'm going to take this and multiply it by this term here and by this term. When I multiply by this term here, they just cancel out, so I'm left with just that x. And then minus 1 times the x plus 2. So negative 2x over x minus 2. So these x values go away. I'm left with negative 2x over negative 2. those go away, and I'm again left with x. So that means that they are inverses of each other. All right, let's find the inverse of this function right here, 2x plus 3 over 5x plus 4. Okay, so we're going to change this to y. Then we're going to change all of our y's to x's and our x's to y's. And then we're going to solve for y, so I'm going to multiply both sides by 5y plus 4. So it cancels out here. And here I have 5yx plus 4x. Just distributing this x to this first and this second term. Then we have 2y plus 3. Now I'm going to move 4x over. 5yx is equal to 2y plus 3 minus 4x. And then I'm going to move 2y over. So we got 5yx minus 2y is equal to 3 minus 4. I'm going to factor out a y, so 5x minus 2 is equal to 3 minus 4x. Divide both sides by 5x minus 2. So y is equal to 3 minus 4x over 5x minus 2. And that will be, well, last thing, change this y to the inverse of x is equal to 3 minus 4x over 5x minus 2. And this will be our final answer. Okay, now let's look at one with a cube root. So we're going to change this to y. And then change our x and y's. Okay, now I'm going to solve for y. So that means I need to multiply both sides, or not multiply, but raise both sides to 3. Because you can write the cube root of x minus 1, y minus 1, raised to 1/3. That means the exact same thing. So when I raise this to 3, I multiply these two together. So that would be 3 over 3, which is 1. Okay, or essentially these just cancel out. So x cubed is equal to y minus 1. And I'm just going to add 1 to both sides. So x cubed plus 1 equals y. And I'm going to change that around. Okay, and then I'm going to change this back to the inverse of x. So that is x cubed plus 1. And this would be our final answer. Okay, now this is just talking about how do you check whether two functions are inverses of each other. Well, what we were doing in the first two examples was we were plugging one function into the other, and if it comes out to be x, or if we switch them up, we plug the other function into the other, and it comes out to be x, well then, and it says if either statement, so you don't have to check both of them, if either statement is true, then that says that they are inverses of each other. But if either statement is false, if one of them doesn't come out to be x, so we can just check one of them. If it comes out to x, hey, they're inverses. If it doesn't come out to x, then they're not inverses. So let's check if these two functions are inverses of each other. And I'm going to plug g into f. Okay, so I'm going to take f, which is right here, and wherever I see an x, I'm going to replace it with whatever g is. Okay, so looks like I can cancel out this negative 3. X minus 5 plus 5, those go away. So it comes out to be just x. So that means that they are inverses of each other. Okay, let's look at this one. I'm going to plug in g into f again. Okay, so this is going to be 2 times x squared minus 7